exponent to an exponent. How does that work? Well, same kind of idea. There's a trick, okay? You can think of the exponent on the outside as like you're multiplying all the other exponents by it. So what I like to do is I like to think about everything having a power. If it's missing a power, it has a power of a 1. So when I distribute this in, almost like I think I'm distributing this 2 to all these little exponents up top, okay? So all the little exponents become, well, multiplied by 2. So this becomes 3 to the 1 times 2 is 2. This becomes actually, well, 4 times 2 is 8. This becomes, let's see, negative 3 times 2 is negative 6. And then z to the, well, 1 times 2 is 2. Now, just like last time, we want to try to simplify this down a little bit more than what we have. Well, this 3 to the second, 3 times 3, that's 9. X to the 8th, I can't do anything with. I'm going to skip the y to the negative 6 for a second, but z to the second, we can kind of shove up here too. Remember, notice I said up here, because this right here, remember when I did last time, when you have a negative exponent, it goes in the bottom. So that means I can now either write this like so, or I could also leave that y to the 6 right here or somewhere in there. But I like this. This looks really nice and lovely to me. That's how that works. But what if you have negative exponents, okay? Where you raise everything to, like, say, a negative third power. Well, same kind of idea happens. I distribute that negative 3 into every single little exponent, okay? So the same exact idea works. Now be careful when you multiply by negatives. For example, this becomes 2 to the, well, negative 2 times negative 3, 2 negatives make a positive. So this becomes a positive 6. Likewise, this becomes a to the negative 5 times negative 3 is 15. And then b to the 4th times b to the negative 3rd is b to the negative 12. Now, hey, we see a negative exponent. We better think about where that's going to go. Same thing here. 10 times negative 3 is negative 30. So, hey, both of these two need to go on the bottom. So what I'm going to do is I'm going to make a fraction. I know I'm going to shove both of these at the bottom in the denominator because, again, if you have negative exponents, they tend to like to go somewhere else. So that kind of goes right here. All right, that's nice. A to the 15th goes there. And then 2 to the 6th, I'll go ahead and tell you. You can use a calculator for that. I got that. That's going to be 64. Beautiful. So that's what this could simplify down to, a nice, lovely thing with no negatives in the exponents. People don't like negative exponents for some reason. But then there's even stranger ones where you have something like a fractional exponent. Now that's a bit odd, but let's do it together. Again, I'm going to put a little 1 right here. This becomes, let's see, again, I'm going to distribute this 1/2 in to everything. Now, sometimes you have weirder exponents than this, but the concept still applies. So again, I'm going to multiply all these exponents by this big old exponent out back. So 1 times 1/2 is 1/2. So this becomes 25 to the 1/2 power. That's a bit odd. But then, okay, this is nice. 1/2 of 4 is 2. That's nice. Oh, this is strange, though. Y to the 3rd, 3 times 1/2 is 3/2. A bit odd. Okay, then z, okay, that's nice. Z, let's see, 2 times 1/2 is 1. So that becomes z to the 1. Do you need the 1? Nah, I'm going to erase it. Boop. So now, we've got everything to a point, but we can simplify it down a little further. Now, a half power is actually the same thing as taking a square root. Here's the reason why. Because if we rewrite this as 25 to the 1st, and then we put this 2 as what is called the index, that is the same thing, right? A square root of 25 is the same thing as 25 to the 1/2. So what this turns into is, well, the square root of 25 is just a lovely 5. X squared you can't do anything with, right? And same thing really for this y to the 3/2. I can't really do anything with that. And also, I can't do anything with this z. However, I could also rewrite, just kind of how I rewrote this 25 to the 1/2 is this. If you want to, you could also rewrite it with the same properties. Notice how this 1 went on the inside as a power to the 25, and this 2 went on the outside as what's called the index of the root, right? So I could also equivalently rewrite this as 5x squared. I'm going to put z right here, and I could in theory write this as the, well, let's see, remember how the 2 in the denominator of the exponent went on the outside of the index? So this has an exponent of 2. You really don't need that 2 there, by the way. It's implied to be a square root, so I don't even need it. I'll erase in a second. Z to the 3rd. That is a square root of z to the 3rd. It's the same thing as somebody saying y, excuse me, that's not a z, it's a y. My bad. One take glory, baby. But yes, you can do it this way as well. You really don't need this 2 right here. But yeah, so that's how another way you could rewrite it. If you don't like those fractional exponents, you could also write it as a root, okay? Again, the 2 is not there because a square root is implied. If it was a 4, yeah, you'd have to put it there, but it's not. That's how you do when you have exponents to exponents. There you go.